A century has gone by since Einstein released his general theory of relativity. Now, scientists has proven him right. UND Professor of Physics and Astrophysics, Wayne Barkhouse, is here to tell us about ripples in space. Thanks for being on the show with us today, Wayne.
Thank you for having me.
We've been hearing a lot lately about gravitational waves. Why is that so important?
Well, it's really the beginning of a new era in astronomy and astrophysics. It's the first time that we've had a direct detection of a phenomenon that's been predicted for over 100 years now.
And so, why is this so important for these gravitational waves to happen after it was predicted for so long?
Number one, it means that the general theory of relativity is correct as far as we can tell today. All facts show that that's the case. The other thing is it gives us a new way to see things that are happening in our cosmos. Other than looking at light of different wavelengths, we now can detect gravitational waves and tell us something about the universe that we not been able to see before via the emission of light.
And you're a member of the Dark Energy Survey. Can you tell us a little bit about that and how your team was a part of it?
Right, so the Dark Energy Survey is a 5-year program to observe 5,000 square degrees of the southern sky. As part of that process, we happened to be on the telescope back in September of 2015 when the gravitational wave was first detected here on Earth. And so we are asked to look in the general area where the gravitational waves are coming from to see if we could see something new appearing in a certain region of the sky.
And so this is something that scientists wait for their whole life, right? How was that moment for you when you found out?
Well, it's fantastic. We've been waiting for 100 years for technology to evolve to the point that allows us to detect these very minute changes in space-time. And so it takes 100 years for that to occur, and we're finally there today.
And how difficult was it for all of you scientists to keep it a secret from the public before the press release?
Well, you never quite keep it a secret today in social media, so there are rumors that spread around on Facebook and Twitter, but you do the best you can to try to keep things quiet.
Okay, and so in a second here, we're going to have a picture up about the gravitational waves. Can you explain to us a little bit what it means?
Sure. So what happens when masses are moving around in space? We think of gravity now as being the curvature of space and time. That's what general theory of relativity tells us. So when masses are moving around like two black holes that are in orbit around each other, they're moving closer and closer together. And that change in the curvature of space generates waves that undulate and propagate through space. And by the time those waves reach here on Earth, there are very minute changes in the spatial dimensions from one place to another. For example, you can imagine the old joke of a spider doing push-ups against a mirror. If you look at space as a gravitational wave passes by, you see small changes in how space is both compressed and stretched in one dimension at the same time. And that essentially is what happens when these gravitational waves pass through any region of space. And it's only now, 100 years later, that we can develop the technology to detect those minute changes in the dimensions of space. And we're talking about changes on the order of a fraction of the size of a proton. And that's amazing when you think about it.
And so is there more than one way that a gravitational wave can be made?
Yeah, so there are many different ways. And what I find most intriguing is we know that gravitational waves should have been produced when the universe was first created. And in some sense, this gives us a handle or a window into the very earliest moments of creation of our universe. It's essentially that we're going to be listening to the birth pangs of the birth of cosmology and everything that we know that ever existed. And we should, in the years to come, be able to detect those type of gravitational waves.
And so scientists have been looking for these waves for years. Why is it now that they were just recently detected?
Yeah, so it's the advancement of technology. We knew they existed. Indirectly, we had evidence of it back in the 70s, and a team of astronomers and scientists won the Nobel Prize in Physics in the 1990s for indirect detection. But here today, we have a direct detection. So there are Nobel Prizes that will be awarded in the near future for this discovery. So people are getting ready to go to Sweden.
And so what doors will this open in the astronomy world for the future?
Right, so it opens the doors of being able to use something completely different now to understand the cosmos at large. Where did our universe come from? How was it formed? Where did the galaxies come from? Where did the planets and the stars all come from? And ultimately, where did life itself come from? How did it arise? It's all tied together. We're all intimately linked to the cosmos.
How do the waves affect space-time?
So what it does is it changes the size of space itself. If you looked at a small region of space, as the waves pass it through, they get compressed and squeezed in different directions. And it's that change in the direction or the spatial extent in these different directions that we can detect here on Earth with our devices such as the LIGO experiment, which was what produced the detection back in September.
Great. Thanks for being on the show with us today, Wayne.
Thank you very much.